You are not joined yet? Ah. Priya, can you hear me? Priya, can you hear me? No. Okay, let's. So in my last lecture, you were on the first lecture of group 15, that is P block elements. First lecture is over. We are on the second lecture. Okay. So now we saw the general properties. Today we are looking at the chemical properties. So when we are looking at chemical properties, first is action of air. So we are talking about chemical properties. So when you talk about chemical properties, first is action of air. See, when we say action of air, it's necessarily action of oxygen in air, basically. So what happens is that all of them, now you see, nitrogen reacts with air and oxygen only in presence of lightning to form nitric oxide. In fact, this is what we mimic when we're going to start talking about preparation of nitric acid. We're going to mimic the nature. That was how they found it first, and then of course get the other method. Then we have phosphorus. All others react directly to form their corresponding what you call oxide. Phosphorus forms phosphorus oxide, and so on and so forth. What is more important for us is action of oxidizing agent. Action of oxidizing acid. So you have to understand, when we talk of mineral acids, so there are two types of acids. One is called as mineral acid, the other is called organic acid. So organic acids are formic acid, propionic, and all that. When we talk of mineral acids, there are two types. One is non-oxidizing acid and the other is oxidizing acid. So HCl and dilute sulfuric acid qualify for non-oxidizing acid. Whereas concentrated sulfuric acid, dilute nitric acid, and concentrated nitric acid, all three of them are called as oxidizing acid. So how do they react? They do not definitely react with nitrogen, but they react with phosphorus. So first we look at concentrated nitric acid. That's an oxidizing agent. So first is what? No effect on nitrogen. No effect on nitrogen. That's the first. So this itself is one of the MCQ. Concentrated nitric acid does not react on nitrogen, phosphorus, arsenic, antimony. So you have to know it does not react with nitrogen, but it does react with phosphorus, arsenic, antimony, and this. And let us see what the products are. So that could be the second multiple choice that they can frame. So when it comes to phosphorus and arsenic, so you have phosphorus plus nitric acid. HNO3 concentrate. I'm not balancing the reaction. You have H3PO4 plus NO2 plus H. Similarly, arsenic, where it reacts with nitric acid, concentrate. What does it form? It forms, this is phosphoric acid. Okay, this will form H3AsO4, that is plus, of course, the same thing, NO2 plus H2. This forms arsenic acid. Fine. But look at antimony. Now, with antimony, nitric acid reacts to form antimony oxide, Sb4O10, and what? NO2 and H2. Very important question. We come to bismuth. When we come to bismuth, the things are different. It reacts, it's a metal. So it reacts with nitric acid. And because it's a metal, it gives the corresponding nitrate, NO3 gold twice, plus 3H2 plus H2 plus. So it's a very important point here, that this reaction, I told you, we can have easily 3 different type of questions being asked. What are 3 different type of questions? First is, which will not react with concentrated nitric acid. So that whatever be the options in the element, nitrogen, phosphorus, arsenic, antimony, nitrogen does not react. Then what do we have? You have phosphorus and arsenic form the corresponding acid, which will form nitrate. So you will have the distractors will be phosphorus, arsenic, antimony, bismuth, like arsenic, antimony. So you have phosphorus, arsenic, antimony, bismuth. Bismuth only forms nitrate. Here both of them form the oxide. Huh? So you can juggle like this: nitrogen, phosphorus, arsenic, and bismuth, which will form oxide. Nitrogen, phosphorus, antimony, bismuth, which forms the oxide on reacting with nitrogen. That kind of a permutation combination is also possible. But this is distinctly a very different question, where we have what you call as nitrate. So this is how the question will be framed. Then the next one is what we have is, what is the other oxidizing acid that we have? The other oxidizing acid that we have is hot concentrated. It is hot concentrated sulfuric acid. Hot concentrated sulfuric acid. So let us look at the reaction. Nitrogen, no reaction. So A, no effect on nitrogen. So in fact, this is one of the anomalous behavior of nitrogen. It is less reactive as compared to the other colleagues in the group 15 or real group members of the group 15. Yeah. Why? Because nitrogen exists as diatomic gas, N triple bond and more bonding. What is the fundamental of any chemical reaction? The reactant bonds have to be broken. If it is a triple bond, reactant bonds will not break. So what will happen? It will be less reactive. So it's the N triple bond N, which is the cause of nitrogen being less reactive. So when it reacts with sulfuric acid, when phosphorus reacts with sulfuric acid, what do you get? You get phosphoric acid, H3PO4 plus SO2 plus H. Then you have phosphorus, you have arsenic plus sulfuric acid. Reacts to form AH3 AsO4, arsenic acid plus SO2 plus H. Whereas what happens with antimony and bismuth? D. With antimony, what happens? It forms antimony sulfate. Sb2SO4 whole thrice plus SO2 plus H. Then E, of course, we have antimony bismuth. Bismuth is also a metal. It reacts with sulfuric acid to form Bi2SO4 whole thrice plus SO2 plus H. So you can see over here again the question that is framed is, which will not react with the concentrated sulfuric acid? a very lame question, but they can ask, see, they can combine 1, 2, 3, and any one of them, which will form the corresponding sulfate. Which will form corresponding sulfate. Which is clear. So that is how the question can be framed over here. So you please take down, okay? Here you can time it for. So next we have a very important reaction which are going to come again and again in the course of our study. That is action of alkali, especially on phosphorus. So you have action of alkali. So what happens is, so nitrogen has no action as usual. What do we have? Alkali, first A. Alkali do not have an action on. Alkali do not have any action on nitrogen. So the first thing is over. Now let us look at phosphorus. Phosphorus reacts with sodium hydroxide, fused sodium or fused sodium. Okay. What does it form? It forms this compound, phosphine plus sodium hypophosphite, NaH2PO, sodium hypophosphite. So what kind of question they can ask? They can give this reaction. It's a very important compound. We're going to study in great detail phosphine. So you can see over here, phosphorus has the oxidation state 0. Here it will have a charge of -3. NaHPO2, NaH2PO2, sodium is +1, hydrogen is +2, oxygen is -4. So what happens is, this will have a charge of 2 + 1, 3, 2 + 1. So here phosphorus has a charge of +1. So when the same substance undergoes oxidation when it undergoes oxidation, it's called as So this is a auto redox or a disproportionation reaction. This is a disproportionation reaction. So it's a redox reaction. So if the question is it's a neutralization and a redox reaction, disproportionation, and displacement, whatever they ask, I would say distractors. It's a disproportion. It's an auto redox reaction. Same substance is undergoing oxidation and same substance is undergoing reduction. So there is the possibility of asking you this question also. So what happens is this question becomes a part of P block and a part of redox reaction of 11th standard. So I told you that yesterday they are trying to combine questions from 2 or 3 chapters into one question. Is this clear? That's how they make it 45. They can make it a little more difficult that what is the change in oxidation state? 0 to -3, 0 to +1, whatever it is, 0 to -3, 0 to +1 in oxidation, 0 to -3 is gain of 3 electrons. How many electrons will be gained? That kind of all possibilities. So 0 to -3 is gain of electrons, 0 to +1 is loss of electrons. It's clear. And same substances are undergoing oxidation as well as reduction. Such reactions are called as disproportionation reaction. Then when we come to arsenic, what happens? Arsenic plus sodium hydroxide. What happens? It forms Na2. Na3As will be sodium arsenide. And we got hydrogen gas. D. Antimony has the same thing. Antimony Sb plus 6 plus NaOH will give you antimony Na3 SbO3 plus H. I am not balancing the reaction. There is no need. Clear? So they form the corresponding song. There is no mention about bismuth, so it is understood that bismuth does not. Clear? So bismuth does not react. So this is the kind of question that we can expect in what we call the part of action of alkali. Next, what do we come to? We come to action of metals. Action of metals. When we talk of metals, nitrogen forms metal nitride. So A, nitrogen corresponding metal nitrides. They form corresponding metal nitrides. For example, with active metals like alkali metal, lithium plus nitrogen forms Li3N, lithium nitride. Lithium. So here, once they ask a very interesting question. See, what is the formula of nitride? Because nitride and azide people confuse. So nitride will have a formula N-3, whereas azide will be N3-. So this was asked once, and people get into trouble. So nitride is N-3, whereas azide is N3-. So remember that. It forms the corresponding nitride. Here, it can react with alkaline earth metals, magnesium, to form Mg3. Then phosphorus reacts to form the corresponding phosphide. Okay, you can have, let's say, magnesium reacting with phosphorus to form Mg3P2. You can have aluminium with phosphorus. So it will be aluminium ALP, aluminium phosphide. See, this aluminium phosphide is used, when you have to kill pests, because there are different methods. One is you can simply make an emulsion, make it a liquid, spray. Okay, like how we do in our fields and all that. Okay, that's a possibility. Then the other one is what you can use a fumigating agent. That means you can just make the fumes and kill. So quite some time back in India, we used to have this aluminium phosphide. What they used to do is they used to simply what people heat it. Aluminium phosphide used to kill, especially bed bugs and all that. One accident happened, when aluminium phosphide entered into the fridge, it was absorbed by the chicken and then the people ate it and they died. So after that, aluminium phosphide as a pesticide was banned in India. I mean, it's still banned. It's clear. So arsenic will form. Arsenic reacts with sodium, Sodium reacts with arsenic to form Na3Az2, sodium arsenide. Magnesium with bismuth. Magnesium with bismuth forms Mg3Bi2. This is bismuthide. This is sodium arsenide. And this is magnesium. This is magnesium bismuthide. Magnesium bismuthide. Okay. So this aluminium phosphide, I told it is used for it all. Now we come to a very, very important aspect of this high drives. A lot of MCQs can be framed on high drives. Let us look at one by one. We are now talking about reactivity, reactivity towards hydrogen. So the first point is all group 15 elements. All group 15 elements form corresponding hydride. All group 15 elements form corresponding hydride. The most important is second point. So all of them are gases. That is the other point. All of them are gases. It is clear. So now what happens is, let us look at the property. So you have the EH distance, NH distance, pH distance. So it is all 100 and it is a picometer. So in case of nitrogen, it is ammonia we are talking. Ammonia has an NH distance of 101.7 picometer. So then we have nitrogen, phosphine, arsine, stilbene, and we have BiH3. So ammonia, phosphine, arsine, stilbene, and BiH3. So this is 107. This is 141.9 picometer. This is 151.9 picometer. This is 170.7. There's no here. This will be ionic. This will be a hydride. So basically what happens, the first question that we can ask is order of increasing order. Increasing order of bond length of hydrides of group 15. So you have increasing orders, ammonia greater than phosphine, greater than arsine, greater than stilbene. You may say it is a very regular thing. See, as the bond length increases, the immediate effect is on bond energy. Bond energy decreases. So if bond energy decreases, what happens? Ammonia is more stable as compared to BiH3. So BiH3 will be less stable and it is going to decompose and give hydrogen. So anything that gives hydrogen will be what? Will be reducing agent. So that will be the next thing. We look at, of course, boiling point. Next is boiling point. Okay. What happens in boiling point is ammonia will be 239.6 Kelvin. Then we have 185.5 Kelvin. Then we have 210.6 Kelvin. Then we have 256, and this is just helium metal, a little more organized. So you have arsine will be 185 is for sorry, 185 is phosphine, arsine is 210 Kelvin, then it is 256, and this will be 290. So you have increasing orders. You can see over here, there's a difference. A, B. Increasing order of boiling point. Increasing order of boiling point of group 15. What happens is you have phosphine less than sorry, this will be ammonia less than phosphine less than arsine. So that is the highest bond length. So phosphine, you can see over here, phosphine 185, then less than arsine, less than ammonia, then less than still being, less than. So which will have the highest boiling point? That's the first question. But this can be very tricky because it's not following some order. So this can be very tricky. Then we come to melting point. So when we talk about melting point, ammonia will have 195. I'll get empty for short, so I get space. No? Melting point. So one more parameter I can take over here. So when I talk about melting point, what happens? Ammonia is 195.3 Kelvin. Then we have phosphine is 139.5. Then this is 156.7. And this is 185. So again over here you can see the third question they can ask is increasing order of melting point. So what will we have? We will have phosphine less than arsine less than stilbene and less than ammonia. So you can see these are this kind of gradation. When they give in the textbook like this as a what you call a detailed value, people tend to neglect. If there are people who tell them don't even bother about it. No, you have to bother because this figure is converted into question like this. Then we have next is HEH angle. So ammonia angle. That of course it follows a regular rate, but then there's a question based on that also. So ammonia will be 107.8 degrees. 107.8. Then we have 93, 91.8, and this is 91. So why? So here you can see there is not much problem because it's a straight HEH band. So why ammonia has? Why in ammonia? NH bond angle is large. So this is a question I can combine with nature of chemical. Nitrogen, phosphorus, arsenic, antimony, bismuth, they belong to the same group. Bismuth, because they're not bothered. It's a metal hydride. These are covalent compounds. As the logic is, as the electronegativity of central atom increases, as the electronegativity of central atom increases, bond angle increases. The reverse will be true for terminal. As the electronegativity of terminal atom increases, bond angle decreases. So PF3 will have lower bond angle as compared to PCl3, as compared to PBr5 and so on. PBr3 and PI. Are you understanding? So there, the terminal will have more, so bond angle will be less. So this is the logic of hydrogen. Then we come to what? Enthalpy of formation. Shall I take it over here? Enthalpy of delta formation H. For ammonia, it is minus 46.29. This is the value of kilojoule per mole. Whereas for phosphine, it is 13.4. Whereas for arsine, it is 66.4. Whereas for this is 145.1. And for this is 278. So here you can see it is very important. So among the hydrides of what you call group 15, only enthalpy of formation of Ammonia is exothermic. This is exothermic, whereas all these are endothermic. So a question can be asked, among the following hydrides, the enthalpy of formation is exothermic form. So that is what happens. They have covered a question in P block and they have covered a question in thermodynamics, enthalpy of formation. So that concept is brought over here to frame a question. So please stay down. Okay. But they were still not over with hydride writing the space, so there was a problem. Okay. We are still not done with hydride. Some more MCQs which can be framed is also there. So what are the other properties? So increasing order of their increasing order of reducing property of hydride. Reducing property of hydride of group 15. I hope this shortcut you remember here. So it will be ammonia less than phosphine less than RC less than stilbene less than bismuth. So now the question is, they'll give you 4. Let's say 1, 2, 3, 4, which is a strong reducing agent. BiX3, because it is less stable, very low bond distribution energy, give hydrogen easily. Anything gives hydrogen is a good reducing agent. That is it. That's how they ask. Then basicity. Basicity also decreases. Basicity decreases. Decreasing order of basicity. So next is 1, 2, decreasing order of basicity of hydrides. Of group 15. So it will be less basic. It will be more basic Ammonia is more basic. Ammonia greater than phosphine greater than arsine greater than arsine greater than stilbene greater than BiH. Okay. So then what happens? Third, smell or odor increases, smell or odor and poisonous nature. Increases as we go down the group. Increases for hydride as we go down the group. So this will be more poisonous. Ammonia is poisonous. Remember that. Beyond 5 ppm concentration, ammonia can be poisonous. Is this clear? Then the fourth one, what do we have? Solubility. Thermal stability. So thermal stability will go on NH3 greater than PH3 greater than arsine greater than stilbene greater than BiH. Okay. So this is all about so many things about hydride. Please take down.
Now,
Yes.
basicity increases.
No, basicity decreases. Because basicity is tendency of what you call ammonia is most basic. I'm very sure. The metallic character of hydroxide, if it decreases, then it is correct. Nah? This is hydride, no? If you're comparing a hydroxide, then the question was different. Here you're talking about basically of hydrides, not hydroxide. Are you understanding? What you have learned is as we go down, okay, what happens for hydroxide, the basicity increases. For hydride, it decreases. Got it? Now, with this, we have a general property. Now we come to anomalous behavior of nitrates. So when we are studying periodicity, if you remember, the second elements of the second period, they have very small atomic size, so they show slight difference in the property as compared to the group. So nitrogen, phosphorus, arsenic, antimony, bismuth. What happens? Nitrogen shows an anomalous behavior. So each point in anomalous behavior is a very important multiple choice question we discuss in detail. It's clear. And of course, in your 12th standard board exam, I mean, I was just looking at what you call today. There's this thing. Bihar board exam this year. It seems 60% of them have failed. I was seeing some YouTube. They are saying some have cleared IIT but failed in EA. It is possible because attempting the board exams is a different game as compared to entrance exam. So sometimes you also be focused on writing some board exam. So here the question of any board exam will be write a note on anomalous behavior of nitrogen. So we'll have next oxygen and then we'll have fluorine. So anomalous behavior of these elements of the second group of the periodic table. So how do we begin this question? Anomalous nature of nitrogen. So first is give an introduction. Why does it show anomalous nature? That is as far as the 12th standard is concerned. And as far as the entrance exam is concerned, each one will be an MCQ on its own, literally. So you say it is because of first and foremost, it is because of small atomic size. Small atomic size and high electronegativity. High electronegativity. After fluorine, nitrogen is the most electronegative element. Then we have oxygen. No, after fluorine it will be oxygen, then nitrogen, and then those halogens. So it's quite electronegative. And that is going to be the problem called hydrogen bonding and all. High electronegativity. And then the third point is what? It is because of high ionization enthalpy. High ionization enthalpy. And last but not the least, what is it? Absence of vacant D. Absence of vacant D summation. So when you begin writing an answer in 12th standard, please start with this. These are the points for which some marks are allotted. They expect you to know. It's clear. I mean, trying to make an MCQ out of this will be difficult. It's just clear. Because nowadays we don't have none of the above and all the above. Otherwise, we could have had 3 points and then all the above. That possibility does not exist. So therefore, so what are the properties? First and foremost, nitrogen is a gas. Nitrogen is a gas. All others are solid. All other members. All others are solid. Okay. So phosphorus, arsenic, antimony, bismuth are solid. Nitrogen is a diatomic gas. It's clear. Now, nitrogen exists as diatomic molecule. Nitrogen exists as diatomic molecule, whereas phosphorus exists as P4, arsenic. Phosphorus, arsenic, antimony, all of them are tetraatomic. And of course, bismuth is a metal. Okay. So here they can ask a question, I'll tell you very easy. Phosphorus, arsenic, antimony, bismuth. Or they can have nitrogen, phosphorus, arsenic, antimony, bismuth. which is not molecular, which is because here they are existing as molecule, whereas bismuth is monoatomic. So that is the question that they can ask, which is not molecular. So they can include, let us say, nitrogen, phosphorus, arsenic, and bismuth. Then we can have phosphorus, arsenic, antimony, bismuth. All of them, these diatomic or tetraatomic, they are molecular in nature, whereas bismuth is monoatomic. This is clear. So that is the question we can expect in this, what we call. I'm always telling you, this is how the questions are framed every year. New questions they're able to get because they go into the very depth of what we call, what are this thing given in the textbook and reference books. Then the third one is what? Only hydride of nitrogen that is NH3 forms hydrogen bonding. Why? Simple, large difference in electronegativity. Large difference. So because of its nature to form what you call hydrogen bond, its solubility will increase. No? Ammonia will be more soluble than the other members of the family because of its capacity to form hydrogen bonding. Then fourth one, what happens? Nitrogen has a tendency to form. Nitrogen has a tendency to form p pi bond. Okay? In compounds. Because it does not have a D or D option. 1s2, 2s2, 2p3, there is no making. Others can form p pi d pi over lambda. So when you come to certain compounds now, you'll be seeing this p pi d. But you want to have compounds of phosphorus and all that. Then you see how the bonding is. This will be explained in great detail. Then the fifth one what we have is nitrogen shows all oxidation state. Nitrogen in its various compounds. Nitrogen in its various compounds shows all oxidation state. Shows all oxidation state from -3 to +5. Others only show -3, +3, and +5. So that I distinctly explained last time. So I'm not repeating it. Then what do we have? Only NF3 is stable. NF3 is stable. So this is an important MCQ that you can have. We talk of compounds of halogen, NCl3, NBr3, and Ni3 unstable. So which is more stable? That is the question we can anticipate over here. Then we have nitrogen does not form pentahalides. Nitrogen does not form NCl5. Why it does not form NCl5? That is pentahalide. Whereas PCl5 exists because it does not have vacant D substitution. It does not have vacant D substitution. See. Then we come to what? See, nitrogen does not form a coordination compound. Means central, you can have a ligand, ammonia, nitrogen as a ligand, hydrazine and all that. But nitrogen, because it does not have vacuum, cannot become a central metal atom or ion in a coordination compound. Here, nitrogen so eighth one, nitrogen cannot be sent. If you were done the shortcut central metal atom or ion in coordination compound, due to absence of d orbit. So these are some of the anomalous behavior of nitrogen. Please copy it down. We finish today's lecture over here. For those who are seeing the live stream, the next lecture will be on Wednesday, same time, 6 o'clock to 7 o'clock. And my students know that it's clear. So we will continue with group 15. We need about 6 lectures for group 15. It's quite a huge topic. It's clear. So I take leave of you. Thank you very much. Good night.